All right, let's talk about object-oriented programming. This is going to be a super quick, rapid-fire review of all the core concepts, so let's just dive right in.
So have you got a big coding interview coming up, or maybe a final exam that's got you a little stressed out? Well, if you need a quick, solid refresher on OOP, you are in exactly the right place.
And here's the deal. We are going to cover the absolute essentials of object-oriented programming in under 5 minutes. That's the promise. You ready? Let's do this.
Okay, first things first. What is object-oriented programming anyway? I mean, what is this whole paradigm that basically powers so much of the software we use every day?
So, at its heart, OOP is really just a way of thinking about and solving problems. It's a programming style, a paradigm that's built completely around this idea of objects. Seriously, everything you do, every single computation, it's all just objects talking to each other.
And if you really want to get OOP, you have to start with its two fundamental building blocks, classes and objects. Everything, and I mean everything else, is built on top of this foundation.
This is probably the best analogy you'll ever hear for this. Think of a class as the blueprint for a house. It has all the plans, right? It defines the structure, the features, but it's not a house. It's just a plan. The object, that's the actual house, the thing that gets built from the blueprint. It's a real instance that takes up space in your computer's memory.
And here's what that looks like in actual code. See that class person part? That's us, the architects, writing the blueprint. But that second line, person OB1, that's the moment we tell the builders to construct the house. We're creating an object, an instance of that person class, and that's the point where memory actually gets used.
Okay, so we have our building blocks. Now, let's get to the really cool part, the 4 pillars of OOP. You can think of these as the superpowers that make this whole approach so powerful.
Yep, there are 4 core principles. And these are basically the rules you follow to build software that's strong, reusable, and not a total nightmare to maintain.
And here are our 4 superstars: inheritance, encapsulation, abstraction, and polymorphism. Let's break them down, one by one.
First up, inheritance. And honestly, it's pretty much what it sounds like. It lets a new class, the child class, inherit all the features and abilities from an existing parent class. This is huge for code reusability. I mean, why reinvent the wheel when you can just inherit the design, right? And this inheritance thing can go on and on. You can chain it together. So here, you've got class C inheriting from B, which in turn inherited from A. It's like a family tree. We call this multi-level inheritance, and it's awesome for creating really specific, specialized classes from more general ones.
Next up, pillar number 2, encapsulation. The big idea here is bundling. You take your data and all the functions that mess with that data, and you wrap them up together in a single protected little package. It's kind of like putting your important stuff in a safe. And this car dashboard analogy is perfect. You use the steering wheel, the gas pedal. You don't need to know the messy details of how the engine is firing its pistons. That's encapsulation. It lets you use something without worrying about its internal complexity, and it protects all that important internal stuff from being messed with accidentally. All right, our third pillar is abstraction. And this one is all about keeping things simple. The whole point is to show only what's necessary to the outside world, while hiding all the complicated, messy implementation details. You just get what you need to see, nothing more.
Now this is a super important point because people get these two mixed up all the time. Abstraction hides the complexity, the how something works. Encapsulation hides the data, the what, by bundling it up safely. One hides complexity, the other hides data.
And that brings us to our final pillar, polymorphism. It's a Greek word that literally means many forms, which is pretty cool. In programming, it just means that one single thing, like a function name, can do different things depending on the situation. One name, many forms. And you'll generally see 2 main types of this. There's compile time, where the computer figures out what to do when you're first building the code. Then there's runtime, which is way more dynamic. The decision of what to do happens while the program is actually running, which gives you a ton of flexibility. This is a perfect example of that compile time type. Look, we've got 3 functions, and they're all named fun. So how does the computer know which one to use? It looks at what you give it. If you give it nothing, it uses the first one. Give it an integer, it uses the second. Give it a double, it uses the third. See? Same name, different actions. That is polymorphism in a nutshell.
Okay, so we've got objects, we've got the 4 pillars. But what about the life of an object? You know, where do they come from and where do they go? Let's take a super quick look at their life cycle.
Every single object's life begins with something called a constructor. It's a special function, always with the same name as the class itself. And the moment you create a new object, boom, this constructor runs automatically. Its whole job is to get the object ready for action, set everything up, and get it initialized. And just like it has a birth, it has an end. At the end of an object's life, its destructor gets called. You can always spot a destructor because it has that little tilde symbol in front of it. And just like the constructor, it runs automatically when the object isn't needed anymore. Its job is to clean up any mess, like releasing memory back to the system.
Whew, okay, we've moved fast and covered a ton of ground. So let's just zoom out for a second and look at the big picture. Why do we even bother with all this? Why is OOP so important?
Because it's not just a bunch of theory, right? It gives you real actual benefits. Thanks to encapsulation and abstraction, your data is way more secure. Inheritance means you're not writing the same code over and over again. And when you put all 4 pillars together, you can build really complex software that's actually possible to understand and maintain down the road.
And there you have it. That's our super fast review. We've hit on classes, objects, and the 4 big pillars that make OOP what it is. So the only real question left is for you. When you get back to your code or start planning your next big project, how are you going to use these ideas to make it even better?